Okay, we're going to talk about lesson 2.6. Having a hard time getting us all together. I'm going to create this little video. We'll see how this works. If it works for us, we might use it again. If it doesn't, we'll just try something different. But I want to talk to you about 2.6, and it's going to cover limits that involve infinity. So the first one I want us to look at is the limit as x approaches infinity of 1 over x. So what's going to happen is, as x approaches infinity, this number on the bottom is going to get extremely large. When it gets extremely large, when you divide 1 by a very large number, it's going to be extremely small. So as this approaches infinity, the limit is going to approach 0. Now, it's never going to actually be 0, but it's going to get very, very close to 0. You're going to use that to solve some problems. For example, I'm going to look at example 2 on page 88. It says the limit as x approaches infinity of 5 plus 1 over x. Now, the way we're going to handle that is we're going to break that into two limits. The limit of the sum is equal to the sum of the limits. So this is really the limit as x approaches infinity of 5 plus the limit as x approaches infinity of 1 over x. Well, we know that the limit as x approaches infinity of 5 is 5. It's a constant. It's not going to change. And the limit as x approaches infinity of 1 over x is 0. So this answer, 5 plus 0, is 5. That's part A. Part B says the limit as x approaches negative infinity of pi square roots of 3 over x squared. Okay, we're going to use our limit rules, and we're going to use the product rule. The limit of the products is equal to the product of the limits. So we're going to break this apart to the limit as x approaches negative infinity of pi times the square root of 3 times 1 over x times 1 over x. Then we'll go ahead, we'll take the limit of each part of that, the limit as x approaches negative infinity of pi over pi, square root of 3, times the limit as x approaches negative infinity of 1 over x, times the limit as x approaches negative infinity of 1 over x. Well, this is a constant, so its value is pi times the square root of 3. And from previous examples, we know that this is 0 and this is 0. It doesn't matter that it's approaching negative infinity. 1 divided by a really, really large negative number is still a really, really small negative fraction or negative decimal value, so it does approach 0. So when we multiply those together, my final answer there is 0. Okay. Limits at infinity of rational functions. So this is going to be similar to what we studied when we did our asymptotes. So we're going to look at example 3. And example 3, I'm still on page 88, says these examples illustrate what happens when the degree of the numerator is less than or equal to the degree of the denominator. So let's look at this one. It says the limit as x approaches infinity of 5x squared plus 8x minus 3 over 3x squared plus 2. Okay. Now, to determine the limit of a rational number, or rational fraction, or function as x approaches infinity, you've got to divide the numerator and the denominator by the highest power of x in the denominator. The result then depends on the degrees of the polynomial involved. So, you must divide the numerator and the denominator by the highest power of x in the denominator. If you don't do that, as x approaches infinity, the numerator approaches infinity, and the denominator approaches infinity, we don't really have anything we can go for from there. So we're going to start this problem. We're going to divide everything by x squared. When you do that, you're going to get 5 plus 8 over x minus 3 over x squared over 3 plus 2 over x squared. Now you can evaluate the limit. Remember that the limit of the sums and the quotient is equal to the sum and the quotient of the limit. So I'm not going to break all of that apart. I'm just going to evaluate each limit as we go. So this is equal to, the limit as x approaches infinity of 5 remains 5. Limit as x approaches infinity of 8 over x. 8 over x is another version of 1 over x, and the larger the denominator gets, the closer the numerator gets to 0. Infinity squared is even bigger than infinity, so the same thing's going to happen. That's going to have a limit of 0. The denominator, 3 is a constant, 2 over x squared is going to be 0. So this has a limit of 5/3. Has a limit of 5/3. Now, in your book, on page 88, I'm going to show that to you real quick. I'm going to look at this picture here. The graph of the function here, the graph approaches the line y equals 5/3. That's the red line right there. Okay? On the positive side, it's going to approach it. On the negative side, it's going to approach it. It's going to cross the line right there. It's going to happen sometimes. Okay, next example. Next example from that same section. Ask us to find the limit as x approaches negative infinity of 11x plus 2 over 2x cubed minus 1. We're going to divide everything by x cubed. So this is the limit as x approaches negative infinity of 11x over x cubed plus 2 over x cubed over 2x cubed over x cubed minus 1 over x cubed. So this is the limit as x approaches negative infinity of 11 over x squared plus 2 over x cubed 2 minus 1 over x cubed. These are all just versions of 1 over x. I mean, if infinity's on the bottom, it's going to go to 0. So this is 0 plus 0 over 2 minus 0, which has an answer of 0. Okay. We're going to talk about horizontal asymptotes. If the distance between the graph of the function and some fixed line approaches 0, if those two things grow closer and closer together as x moves away from the origin, then it's an asymptote. Looking at f of x equals 1 over x, we observe that the x-axis is an asymptote. So let me put that in the calculator real quick and we'll look at it together. Okay, the x-axis is an asymptote. It gets increasingly close, but it never actually touches it because it's never actually going to be 0. That's our example, and so that x-axis is a horizontal asymptote. A line y equals b is a horizontal asymptote if the limit as x approaches infinity of f of x equals b, or the limit as x approaches negative infinity of f of x is b. So b is my horizontal asymptote if it's the limit as x approaches infinity. Makes sense, doesn't it? Okay, here we go. The graph of this function that we just looked at, 5x squared plus 8x minus 3 over 3x squared plus 2. Let's look at its graph. Remind you that it's graphed here. Okay. It has the line y equals 5/3 as a horizontal asymptote because the limit as x approaches infinity was 5/3 and the limit as x approaches negative infinity would be 5/3.